Hi, my name is Mike Rose, and I'm a professor in the chemistry department at the University of Texas at Austin. Today I'd like to tell you about a new and exciting outreach program that we're developing called H2 from H2O. The program is designed to bring hands-on water splitting as an experiment directly into the hands of high school chemistry and middle school science students. In our last video, we discussed the importance of H2 and where it comes from. So now let's have a look at the electrolysis kit that we can use to make H2 and O2. The kit controls the amount of electricity going into the reaction using two control knobs that allow you to adjust the current. As a result, this controls the rate of the chemical reaction. A really great thing about this experiment is that you can actually see the products forming right in front of your eyes on the electrodes because the products of the reaction are both gases. On the gas collection tubes, you can use the volumetric lines to determine which side makes hydrogen and which side makes oxygen. Please be a little careful with the electrode tubes, as the glue can fall off if you're not careful when handling them. Now, let's go through the list of how to really get this experiment going. First, let's put on our goggles before we do any chemistry. Next, make sure the power switch at the top left of the kit is off, and that the selector switch at the bottom right is in run mode. Next, take the AC adapter and plug it into a standard electrical socket and set it to 12 volts. Then, connect the output plug to the input on the top left side of the kit. Now let's set up the electrodes. Fill up the beaker with water. Regular tap water will work just fine. Measure out about 3 big scoops of our electrolyte, sodium sulfate, and add it to the water. You might have to stir it for a minute or two to help it to dissolve. Sodium sulfate is non-acidic, non-basic, and non-toxic, so you can handle it without any special precautions. Okay, the next part is a little tricky. Fill up the paired electrode tubes with the electrolyte solution. Be sure to fill them all the way to the top. Next, angle the tubes and the beaker at about 45 degrees to each other, and then quickly and simultaneously invert and submerge the electrode tubes in the beaker, like this. This part even takes me a few tries to get right. The goal is to have about 1 ml of air trapped inside the electrode tube in the headspace. Make sure to record the initial volume in milliliters. Lastly, use the alligator clips to connect each electrode tube to the terminals on the right side of the kit. Each electrode is the same, so it doesn't matter which alligator clip connects to which terminal. Make sure that after both clips are connected to the electrodes, they aren't touching. Now, your experiment is ready to go. Thanks for listening, good luck, and have fun with the experiment. Now, if you want to be completely renewable, we've provided you with a way to take the experiment to another level. Each classroom kit comes with a small solar panel. So if you're lucky and it's a sunny day, you can unplug your device from the wall and plug it into the sun. Once you're outside in a nice sunny spot, use the terminals coming from the back of the solar panel to connect it to the kit. Remember where you plugged in the AC adapter? Well, right next to that are 2 terminals where you can attach the alligator clips that will connect it to the solar panel. Now point that solar panel at the sun and away you go with solar electrolysis. Just imagine, we could cover entire buildings like your school, cities, or even countries with solar panels and hydrogen fuel generators. We would reduce our CO2 emissions and provide great jobs in the manufacturing industry and for chemists like me.